Chapter 8, Introduction to Trigonometry. The presentation is structured as follows. 8.1, Introduction. 8.2, Trigonometric Ratios. 8.3, Trigonometric Ratios of some specific angles. 8.4, Trigonometric Identities. 8.5, Summary. Introduction. Trigonometry is the branch of mathematics that studies the relationships between the sides and angles of triangles, particularly right-angled triangles. The word itself is derived from the Greek words tri, meaning three, gon, meaning sides, and metron, meaning measure. Trigonometry has many real-life applications, such as calculating the height of the Kutab Minor or the width of a river without direct measurement by forming a right-angled triangle and using trigonometric principles. Trigonometric ratios. In a right-angled triangle, we can define 6 trigonometric ratios for an acute angle, such as angle A. Sine of angle A, written as sin A, equals the length of the side opposite to angle A, divided by the length of the hypotenuse. Cosine of angle A, written as cos A, equals the length of the side adjacent to angle A, divided by the length of the hypotenuse. Tangent of angle A, written as tan A, equals the length of the side opposite to angle A, divided by the length of the side adjacent to angle A. Cosecant of angle A, or cosec A, is the reciprocal of sin A, which is the hypotenuse divided by the opposite side. Secant of angle A, or sec A, is the reciprocal of cos A, which is the hypotenuse divided by the adjacent side. Cotangent of angle A, or cot A, is the reciprocal of tan A, which is the adjacent side divided by the opposite side. Properties of ratios. A key property of trigonometric ratios is that their values for a specific angle do not change even if the lengths of the sides of the triangle change. As long as the angle remains the same, its sine, cosine, and other ratios will also remain the same. Example 1. Finding all ratios. Problem. Given that the tangent of angle A equals 4 divided by 3, find the other trigonometric ratios of angle A. Solution. Since tan A is the ratio of the opposite side to the adjacent side, we can represent the opposite side as 4k and the adjacent side as 3k. Using the Pythagoras theorem, the hypotenuse is the square root of 4k squared plus 3k squared, which equals 5k. With all three sides known, 3k, 4k, 5k, we can find the other ratios. Sin A equals 4k divided by 5k equals 4/5. Cos A equals 3k divided by 5k equals 3/5. Cosec A equals 1 divided by sin A equals 5/4. Sec A equals 1 divided by cos A equals 5/3. Cot A equals 1 divided by tangent A equals 3/4. Example 2. Proving angle equality. Problem. If angle B and angle Q are acute angles and the sine of B equals the sine of Q, prove that angle B equals angle Q. Solution. In their respective right triangles, sine B equals AC over AB and sine Q equals PR over PQ. Since they are equal, we can establish a proportion. AC by PR equals AB by PQ equals K. Using the Pythagoras theorem, we find that the ratio of the third sides, BCQR, also simplifies to K. Since the ratios of all three corresponding sides are equal, the two triangles are similar by the SSS similarity criterion. Therefore, their corresponding angles must be equal, which proves that angle B equals angle Q. Example 3. Calculating with ratios. Problem. In a right-angled triangle with a hypotenuse of 29 units and one side of 21 units, let the included angle be theta. Find the values of cosine squared of theta plus sine squared of theta and cosine squared of theta minus sine squared of theta. Solution. First, find the length of the third side using the Pythagoras theorem, which is the square root of 29 squared minus 21 squared, equaling 20 units. Determine the sine and cosine of theta. Sin, the equals 20/29 and cos equals 21/29. Calculate the required values. Cosine squared theta plus sine squared theta equals 21/29 squared plus 20/29 squared equals 441 plus 400 divided by 841 equals 1. Cosine squared theta minus sine squared theta equals open parenthesis 21 over 29 close parenthesis squared minus 20/29 squared equals 441 minus 400 divided by 841 equals 41 by 841. Example 4. Verifying an identity problem. In a right triangle ABC, if tan A equals 1, verify that 2 times sin A times cos A equals 1. Solution. If tan A equals 1, then the opposite side, BC, equals the adjacent side, AB. Let's call their length K. The hypotenuse AC is then the square root of K squared plus K squared, which is K times the square root of 2. This gives sin A equals 1 over the square root of 2 and cos A equals 1 over the square root of 2. Substituting these into the expression 2 times 1 divided by the square root of 2 times 1 divided by the square root of 2 equals 2 times 1/2, which equals 1. The identity is verified. Example 5, finding ratios from sides. Problem. In triangle OPQ, right-angled at P, OP equals 7 centimeters, and the difference between OQ and PQ is 1 centimeter. Find the values of sine Q and cosine Q. Solution. We are given OQ minus PQ equals 1, so OQ equals 1 plus PQ. Using the Pythagoras theorem, OQ squared equals OP squared plus PQ squared, we substitute 1 plus PQ for OQ. Solving the equation, 1 plus PQ squared equals 7 squared plus PQ squared gives PQ equals 24 centimeters and therefore OQ equals 25 centimeters, sin Q equals 7/25, cos Q equals 24/25. This slide provides a table with the values of the trigonometric ratios for the angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. A key observation is that as an angle increases from 0 degrees to 90 degrees, its sine value increases from 0 to 1, while its cosine value decreases from 1 to 0.0. Examples with specific angles. Example 6. In a right triangle with one side of 5 centimeters and an angle of 30 degrees, find the other sides. Using the tangent of 30 degrees, we find the length of side BC to be 5 times the square root of 3 centimeters. Using the sine of 30 degrees, we find the length of the hypotenuse AC to be 10 centimeters. Example 7. In a right triangle with sides 3 centimeters and 6 centimeters, hypotenuse, find the acute angles. The sine of angle R is 3/6 equals 1/2. Therefore, angle R equals 30 degrees. By the angle sum property of a triangle, angle P must be 60 degrees. Example 8. Solving for angles. Problem. If sine of A minus B equals 1/2 and cosine of A plus B equals 1/2, find angles A and B. Solution. Since sine of A minus B is 1/2 and cosine of A plus B is 1/2, we can conclude that A equals B. 1/2, the angle A minus B must be 30 degrees. Since cosine of A plus B is 1/2, the angle A plus B must be 60 degrees. Solving this pair of linear equations gives A equals 45 degrees and B equals 15 degrees. Trigonometric identities. An equation involving trigonometric ratios of an angle is called a trigonometric identity if it is true for all values of the angle. The 3 fundamental Pythagorean identities are cosine squared A plus sine squared A equals 1, 1 plus tangent squared A equals secant squared A, cotangent squared A plus 1 equals cosecant squared A. Proving identities. Example 10. Prove that secant A times 1 minus sin A times secant A plus tangent A equals 1. Solution. By converting all terms to sine and cosine, the expression simplifies to 1 minus sine squared A divided by cosine squared A. This is equal to cosine squared A divided by cosine squared A, which equals 1. Example. Prove that cot A plus cos A equals cosec A 1 cosec A plus 1. Solution. By rewriting cotangent A as cosine A divided by sine A and then factoring out cosine A from the numerator and denominator, the expression simplifies to the required form. Example 12. Advanced identity proof. This slide demonstrates a more complex proof for the identity. Sin theta, cos theta plus 1. Sin theta plus cos theta. 1 equals 1. Sec theta, tan theta. The solution involves dividing the numerator and denominator by c cos theta, then using algebraic manipulation and the identity sec squared theta equals 1 plus tan squared theta to arrive at the right-hand side. Summary. Here are the key points from this chapter. Definitions of sin A, cos A, and tan A in a right-angled triangle. Reciprocal relationships. Cosec A equals 1 over sin A sec A equals 1 over cos A, and cot A equals 1 over tan A. Also, tan A equals sin A over cos A. If one trigonometric ratio of an angle is known, the others can be found. The specific values of trigonometric ratios for angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. The value of sin A or cos A never exceeds 1, while sec A or cosec A is always greater than or equal to 1. The three Pythagorean identities, sin squared A plus cos squared A equals 1, sec squared A minus tan squared A equals 1, and cosec squared A equals 1 plus cot squared A. Thank you for learning with us.